Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Equality Cages 144, Equality Islands by Gubler and Jasura. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in each empty cell, and digits must not repeat within the same row, column, and or box. We have Nurikabe, where we need to color the grid so that some cells are island and some cells are water. Islands are a group of orthogonally connected cells, the size and shape of which must be deduced by the solver. All the water must be orthogonally connected. Islands may not touch each other orthogonally, and no 2x2 area may be fully water or fully island. So this is a very different, well, not very different, but this is not, that last part is not normal Nurikabe. Nurikabe, you could have 2x2 areas that is fully island, but in this puzzle specifically, no 2x2 area can be fully water or fully island. So keep that in mind. So all the water has to be orthogonally connected. What does that mean? It means you can go from any cell that is water, and it can go to any other cell that's water just by going through edges, all while staying within the water region. So this could be an example of a valid water, because it's basically going, you can go from any cell in the water region to any other cell in the water region just by going through edges while staying within the water region. This is not, however, because this cell can't get from, can't go to any cell in the water region by just going through edges while staying within the water region. This also is not valid because these two cells, even though they can go to each other by going through edges while staying within the water region, cannot go to any other cell in the water region just by going through edges while staying within the water region. So that's an example of how Nurikabe, or specifically orthogonally connected cells, work. Okay. We have circles, where all circles are water. And the digit inside the circle indicates how many water cells can be seen in an orthogonal direction, in any, orthogonal direction, including itself. And island cells block vision. So, what is an orthogonal direction? It's basically just horizontal or vertical direction. So, for example, this cell sees how many water cells? It sees 1, 2, 3, 4, and 5, right? Because it would see itself, it would see these cells, and assuming that these were all island cells, it could not see this cell because it would be blocked by island cells. So this would be 5 in that case. This would be 4. Obviously, this is problematic because the all cages cells... Oh, wait, it's all circles. Apologies. So if we do circles, this would see 1, 2, 3, 4, 5, 6, 7. So that would be 7 there. Say this included a blue. So then this would be basically 1, 2, because it would not see these cells because it would be blocked by island cells. And that's an example of how circles work. We have cages where all the cage cells are on an island, and the digit inside the cage indicates the size of the island. And there is exactly one cage cell on each island, and its shape must be deduced by the solver. So obviously this doesn't quite work. Let's see if we can come up with an example that might. So say we had something like this. Then this would be size 2. And so it would have to be 2. And say we had something along the lines of this or whatever. then this would be size 4 because it's 1, 2, 3, 4. And therefore the digit in the cage would have to be a 4. We also have equality cages, where all islands are their own equality cage. I don't know what that means. All islands must have an equal number of low and high digits, with low digits being 1, 2, 3, and 4, and high digits being 6, 7, 8, 9. And an equal number of even digits, which is 2, 4, 6, 8, and odd digits, which is 1, 3, 7, 9 digits. Islands can never contain a 5, so 5 is always going to be in water. And digits may not repeat on an island. That's interesting. Huh. Okay, so there are no repeats on islands. Islands must have an equal number of low and high digits, low being 1 through 4, high being 6 through 9, and an equal number of even and odd digits, the evens being the regular evens, 2, 4, 6, and 8, and the odd digits being 1, 3, 7, and 9. Huh, that's interesting. And again, digits cannot repeat on islands, and islands can never contain a 5. We also have XV, where adjacent cells connected with an X must sum to 10, and adjacent cells with a V must sum to 5. Not all X's or V's are shown. So for example, if this were, say, a 3, this would have to be 7, because these two digits must add up to 10, because there's an X between them. If, say, this was a 2, this would have to be 3, because these two digits must add up to 5, because there's a V between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, all the circles are water. All the cages are island. But we know there's an equal amount. The cages basically give you the size of an island. And all islands have an equal number of low and high digits and an equal number of even and odd digits. So therefore, it must be an even digit. It must be 2 times something, right? Because you have an equal number of odds and evens and lows and highs. And that, therefore, it's always going to be 1. It's going to be 2 times 1, 2 times 2, 2 times 3, or 2 times 4. So all the islands have to have 2, 4, 6, or 8. Obviously, these cannot be 6 or 8. Also, we have a problem where, so water must always be orthogonally connected to each, to the rest of the water cages. So you can never have a water cell just by itself, so it will always see greater than 3 cells. Or sorry, greater than 1 cell in orthogonally, right? Because it has to connect to the rest of the water cells orthogonally. So this can never be 1, which means this is 2 and this is 3. So this is 2, that's 3. Water has to orthogonally connect, so it must go this way. Same here, it must go that way. 2 eliminates 2 from being here. This sees water at most 1. Well, 2 eliminates 2 here. So this has to be at least 4 in size. It cannot, can it not be here? If it goes here, then these would connect as an island, but each island has its single cage, right? There's only 1 cage cell on each island, so that's not allowed. So this must be part of the island. That means this must be water, because if they were orthogonally connected, they would be on the same island. So the 2 has to go here. And this cannot orthogonally connect with any other land. So must be water. One of these has to be island, because, or land basically, because otherwise it would have a 2x2 area that's all water. 4 has to be, means goes there. It cannot orthogonally connect to either of these two, because then these would be in the same island, and we, again, only one cage per island. So this has to go this way. So these are both water. This must be island here to give this 4 in size. So this cannot be 4 here. This cannot be 4 here. So that's 2 that way. This must orthogonally connect the waters. So that's water. This must go this way. This must orthogonally connect to the waters. So this is size 2. This is water, so it has to orthogonally connect to the rest of the water. So it goes that way. What size can this be then? It cannot connect to here because then this would form an island with 2 squares. So it must be size 2. So this is 2. Obviously, it goes either here or here, which means this can never be island because that would connect that to the rest of this box. Okay, this only sees 3 cells, so this cannot be. So orthogonally, it already sees 3 cells, so this must be land. This must be land. This has to orthogonally connect, so it has to go that way. This cannot connect to here, and it must be 2, 4, 6, or 8, so this must be size 2, which means these are both water. This cannot be a 2x2 area that's all water, so this can't be water, it's land, which means this is water since this is size 2. This sees 3, that's done. So this has to be a high digit, because we have, and it has to be a high odd digit, because we have a low even digit, and we have to have an equal amount of even and odd digits. So this is 7, 9. We have 7, 9 here for the same reason. This, okay, could be there. This sees 3 cells, so this must be 3. That's 3 in the corner. We celebrate because, I don't know, we're getting closer to solving this. This sees right now 1, 2, 3, 4, but it cannot be 4 because of 4 in the box. So this must be water. Since this is water, this is a 2x2 area that has 3 waters. This can't be water. So this must be land there. So this sees 5, 1, 2, 3, 4, 5. It could be up to 7. So this is 5, 6, or 7 here. This sees at most 1, 2, 3, 4. Sorry, it sees 2 at least. It cannot be 3. It must see at least 4 or 5. So it sees 1, 2. It must see these 2 because it can't be 2 or 3 because of 2 in the column and 3 in the column. This is a 2x2 area that's all water. So this must be land. And the water needs to orthogonally connect, so this must go this way. Then here. And this has to be part of an island with a cage, because each island, there's exactly 1 cage cell on each island. If we close that off, this is an island, but then it doesn't have a cage. So this must be green. This is a 2x2 area that's, whoa. This is a 2x2 area that's all green, so this cannot be green, it's blue. This has to orthogonally connect to the rest of the blues. This needs a cage, so we have to go that way. This cannot be part of this island, and this is already size 4. This must orthogonally connect to here, to the rest of the waters. So this can't be 6 or 8 because it's only size 4 at most, so this must be 2. So this is size 2. It could be blue, green that way or green that way. We're not sure. That eliminates... this can't be 2 anyways. This must orthogonally connect to the rest of the water. So this is water here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's too large to be part of this. So this must be part of this island here. It has to go here then. Well, technically, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it cannot go around. It must connect there then. So this is at least size 6. Hmm. This sees up to 9. No. So it must see at least, it can't be 2, 3, 4. Obviously can't see 1. So this must see at least 5. So that must see 5 this way. And it cannot be a full 9 because this cell sees all of those cells and any additional cells this way. So this can't be 9. We have a 2 by 2 that's all water, so this can't be water. This is land, so this has to be size 8. This has to see at least one island, otherwise these see the same cells, or see the same water and in column 1, and therefore they would be the same digit. So this must be blue, this must connect as green. We have a 2 by 2 here, that's all water, so this can't be water, it's green. So this is size 8. Okay. That means this is already size 8, so these have to be non-islands. This is 2 by 2 that has water, so this can't be water. This is land. The water must orthogonally connect, so that it orthogonally connects 2 by 2. That's all water. So this can't be water here. This is land. It has to orthogonally connect to a cage. This could be part of that. We don't know. So this sees size 6. So this is 6, and this must be 7, which makes this not 7. That's 9, which makes that 7. This sees 2. It cannot see 2. It must see 3 waters. So this is 3. This must orthogonally connect here. We don't know about this. So this cannot be 3. 7 cannot be because of 3 in the box, cannot be 2, 8. So this is 1, 9 or 4, 6 here. Okay. We have 7 here, 7 here. On this island, there are 8 digits. There are no repeats, so and there's no 5. So there has to be all the digits from 1 through 9 here. This obviously can't be 7. This can't be 7, so this must be 7 here, which makes this 9, this 9. This obviously can't be 7. It sees only 5, actually, so this is 5. Remaining digits in row 3 are 1, 4, and 6. So that's 1 and 6 here. 1, 4, 6. 1, 4, 6 here. Can't be 6 because of 6 in the box. Okay, 9 eliminates 9 here. So this has to be 4 and 6. That eliminates 4 and 6 remaining in box 7. So this can't be 4 or 6. This must be 8. So it has to orthogonally connect. 1, 2, 3, 4, 5. Can this ever be part of this without being part of... Obviously can't be part of this if that were the case. So then if it were, this would be 8 size here. But then the problem is this would be 8, and it would orthogonally connect to this part here. So this must be part of this island here. So it must break here. We don't... obviously, one of these has to be water to orthogonally connect the water. So we have 1, 2, 3, 4, 5, 6. We have 7, 8 remaining. So it could be 7, 8, 7, 8, or 7, 8. So it cannot be 7, 8 here. 3, 4, 5, 6, 7, and that does not orthogonally connect. So this has to be green also, right? It's either 1, 2, 1, 2, or 1, 2. Okay. So this is blue or green. If this were size 4, the problem is this would be a 2 by 2 area that's all blue. So this cannot be size 4. Can it actually be size 8? 1, 2, 3, 4, 5, 6, 7. Cannot orthogonally connect there. Cannot orthogonally connect there. If it goes here, that's a 2 by 2 area that's all green, which is not allowed. So the answer is this can't be 8. So this is 6, which makes this 4, which makes that 6. One of these is blue. We don't know which. Remaining digits in this 8 island. Actually, what's the remaining digits in this 8 island? Okay, this cannot contain... okay, remaining digits in row 1. Let's do that. We have 1, 5, 7, 8. Okay. No 5 here. Remaining digits in box 7. We have 1, 2, 5, 7, 9. No 2 here, no 2 here, no 2 here. So we're guaranteed, and this can't be 7. So we're guaranteed a 2 here. So that means the rest of the digits on the 5 can never be on an island. So no 5 here. This is 1, 2, 9 as a triplet, which eliminates 1, 2, 9 in the rest of the box. This can't be 1 or 9. It can't be 5 because it's on an island. So that's 7. This is 5. That means we're missing a 3 on this island. And it cannot be here because that would be 3 there. So therefore, this must be water. This is a 2 by 2 area that's all water. So this can't be water here. It's land. So one of these is a 3. We're not sure which. We have 1, 2, 9 as a triplet in column 1. This can't be 1. So that's 4, which eliminates 4 here. We have to have a 3 here, which means we have to have a 3 somewhere here. Remaining digits of column 3 are 1, 2, 3, and 5. No 2 here, no 2 here. Okay. Remaining digits of column 1. We have 3, 5, and 8. This can't be 8. This has to be 3, 5. This can't be... This in this box 1, we have 1, 3, 5 remaining. This can't be 3 or 5. So that forces this to be 1, which means this can't be 1 here. We have 3, 5, or 8 here remaining. Remaining digits in... So this has to be 8 here. Remaining digits in column 2 are 4, 6, and 9. Obviously, that can't be 9 because of 9 in the row. And that's all we have there. Remaining digits in row 2. Cannot be 2, 3, 4, 5. Can't be 1 here, so it's 6, 7, 8, and 9. Okay, so this is definitely a high digit, which means we need a... Oh, 5 cannot be on an island. So, oh, this can't be 5 either, because 5 can't be on an island. This has to be a high. We are guaranteed one of these is a 1. Because we need a low remaining for 2 lows in this island, which eliminates 1 from being here. 9 eliminates 9 here. This is 6. This must orthogonally connect to the rest of the waters. So this has to be water, which means this is the last land here. This must connect to water, so that's there. So this is a 3 here. This must have 6 cells, so this is land here, which means this orthogonally connects this way. So this must be land here, and it must be 7 or 9 to balance off the 2, which is low and even. So this must be high and odd, which is 9. This sees 4 cells, so that's 4, which eliminates 4 here. This cell sees 1, 2, 3, 4. 9 eliminates 9 here. So that's 1, no 1 here. This has to be 4. Okay, where are the remaining digits? 5 can't be here, 5 can't be on an island, so 5 has to be here, which eliminates 5 being here. 5 cannot be here, and it can't be in here or here, so this is 5 here. Where's 5 then in row 9? It has to be here, which makes this a 6, which eliminates 6 there. 5 has to be one of these two. 5 can't be here, 5 can't... Where's 5 in row 4? Cannot be here, so it must be one of these two. So let's just double check. This sees 6 island water cells. 3, 1, 2, 3, 4, 5. 3, 1, 2, 3, 4. 1, 2, 3, 4. And 3. This has size 4, size 2, size 2, size 8. 5, 6, 7, 8. 2, 2, 6. 2. And then this is 8. So those are cages and circles are all done. We just need to figure these out. Okay. Remaining in column. Well, where's the 4? In column 7. Can't be here because of 4s in the boxes. Can't be here because of 4 in the row. So 4 has to be here. And this must have an equal amount of evens and odds. So it can't have 4 because of 4 in the boxes and rows and columns here. So it must have 2 and 8. 2 cannot be here because of 2 in the box and row. 2 can't be here because of 2 in the column. So 2 has to be here, which eliminates 2 here. So that's 9, which makes that 2. Remaining digits of row 7 are 1, 7, 8, 9. This cannot be 9 because of 9 in the box. We have a 1, 7, 8 triplet in column 7, which eliminates 1, 7, 8 in the rest of the column. This can't be 1, 7, or 8. It's 3. This can't be 9 because of 9 in the column. Where is 9 in row 7? It must be here. So 1, 3, and 7 are all odd. 2, 6, and 8 are all even. 1, 2, and 3 are low. 6, 7, and 8 are all high. So that works there. Remaining digits of box 6 are 1, 6, and 8, which eliminates 1, 6, and 8 in the rest of the column. No 6 and 8 here. This can't be 1 or 8. That makes this 7, which means that can't be 7 here, so that's 9. No 9 or 7 here. This can't be 7 anymore because of 7 in the row. That leaves this digit as a 3. And remaining digits in box 9 are 1 and 8. Okay. Remaining digits in box 8 are 1, 7, and 8. What about... remaining digits in row 2. We have 4, 6, 7, 8. And this can't be 6 because of 6 in the column. And this is fine. What about this island here? We have no 5, obviously. 1, 2, 3, 4, 6, and 9. So no 9 or 2 here. No 2 or 6 or 3 there. No 3 or 9 here. Interesting. Okay, 3 eliminates 3 as a possibility here. That means this can't be 3. No 3 here. If this were a 3, it would see all the other cells on this island and therefore would cause problems. Because then there would be no 3 on the island, even though we have to have 8 distinct digits and 5 cannot be on the island. So that wouldn't work. So this cannot be 3. This must be 8, which makes this 5. So this cannot be 5 here. 5 eliminates 5 here. So that's 3, which makes this 5. 5 here, 5 here. 3 is one of these two. 3 is on the island here. So 3 cannot be here on the island. So 3 has to be here, which makes this 5. 3 eliminates 3 here, so that's 1, which makes that 2, which makes that 3. We can no longer have a 1 left on the island, so, and we need a 2 on the island. It has to be here. So that's 2. That gives us, we should have been able to do the, well, we didn't know that was a 2. Anyways, that's 2 here. We have 4, 6, 9 as a triplet, which eliminates 4, 6, 9 in the rest of the row. And this can't be 6 or 8, so that's 1. This can't be 1 here. No 1 here. Okay. 4 eliminates 4 here, so that's 6, which eliminates 6 here. So that's 4, 9 as a pair. Remaining digits in row 6 are 1, 6, 7, 8, and 9. No 6 here, though, because of 6 in the box. No 9 here and here, because of 9s in the columns. We have a 1, 7, 8 triplet, which eliminates 1, 7... Oh, well, we should have known, because that 5 eliminates there. So therefore, this must be 5 here, as the only possibility. We have 1, 7, 8 as a triplet in column 4, which eliminates 1, 7, 8 in the rest of the column. This can't be 1, it's 6. This can't be 6, 7, 8, it's 4, which eliminates 4 here. We have a 7, 8 pair in box 2, which eliminates 7, 8 in the rest of the box. This can't be 7 or 8, it's 1, which eliminates 1 here. So this is 7, 8 as a pair, which eliminates 7, 8 in the rest of the box. This can't be 8, it's 6. Which makes this 1, which makes this 8, which makes that 1, which makes that 8. There's no 8 here, no 8 here. 1 eliminates 1 there. Okay, remaining digits in this cell here could be 4, 6, or 8. No 6 because of 6 in the column. This is 1 and 9, so that's 2 odds. We need 2 more evens to match, so this is 4 and 8, which makes this 7, which makes that 8, which makes that 7. 7 eliminates 7 here, so it's 1, which makes that 7. This can't be 1 or 7, it's 8. This 7 eliminates 7 here, so it's 1. This 8 eliminates 8 here, so it's 6, which makes that 8. 6 eliminates 6 here, so it's 9, which makes this 4, which makes that 6. 8 eliminates 8 here, so it's 4, which makes this 9. This can't be 8 or 9. It must be 7. And that's the solution. Fairly straightforward. Yeah, just fairly straightforward. It's not too hard. Probably a little easier than challenging, but I'm fine labeling it challenging because it's not quite easy enough for easy. And I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.